your patience and welcome to the Eel-Russian Project Authority meeting of March 19th, 2024. My name is David Rabbit. I'm the chair of this body, and I represent the Sonoma County Water Agency. I'm also a supervisor from Sonoma County, and I'll look to Candace to have a roll call, please.
Candace, we can't hear you.
Director Glenn McGordy.
Present.
Director and Chair David Rabbit.
Here.
Director James Russ.
Here.
Director Janet Polly. Here. And Director James Gore is absent.
Candace, I apologize. I went out of habit to do the roll call, and I could have recognized that we're all here with the exception of Director Gore, who did have a last-minute interference come up. So I'll look to my colleagues for the approval of the agenda. I think we all have the agenda and want to make sure that we all...
I make a motion to approve the agenda.
I'll second it.
We have a motion and a second. On this one, can we do a voice vote? We can. So all those in favor of the agenda, please say aye.
Aye.
Are there anyone opposed? Hearing no opposition, that does pass with all present. Thank you very much. And we'll move on quickly to public comment. This is your opportunity to provide public comment to this board. Anyone out there would like to speak to this body? Please.
Hi, my name is Frank Lynch. I'm a familiar face to some of you anyway. I live in Supervisor Gore's district. He's not here, unfortunately, but I also own property in Ukiah Valley, and I'm a lifelong recreational or seasonal user and property owner at Lake Pillsbury. And I also, unfortunately for me, was elected president of the Lake Pillsbury Alliance. I know this isn't on your agenda today, but I need to show up periodically and just reiterate the same information I've said before. I appreciate all your efforts to secure water for all the downstream users and the economy of the area. It's very important to all of us. And I know your focus is on retaining those water resources. We've had a good couple of years of rain, but only a few years ago, Lake Mendocino was within a few weeks of going dry for all of us. So I think that needs to be kept in mind. To date, there's not been a whole lot done to find the alternative water sources that we're all going to need with the demise of Pillsbury. And I know there's some money out there for grants that people have been talking about for studying raising Coyote Dam, building a dam in Potter Valley, doing a pump back system to Potter Valley, but that's all way down the line and probably hundreds of millions of dollars away. I also appreciate the efforts to preserve and protect fisheries. But the dam is not the only cause for the decline of the fish. About 8% of the watershed of the Eel River lies behind Scott Dam, and only a small fraction of the water within the Eel River system is diverted to the Russian. There are lots of issues around fisheries in Pillsbury, but Lake County, the Mendocino National Forest, and a lot of us are being held to, this is going to be a big hit for all of us, and it's going to be very damaging to the environment. Alternatives should be considered. I know you're not there yet, but studies to date have only focused on the dam being removed as the final conclusion. I think a cost-benefit analysis of rehabilitating the dam should be considered in the future, and alternatives to removal of the dam should be considered, and retention of it should be kept in mind. Again, beyond the scope of what you're hearing today, but please keep that in the back of your minds, and I appreciate your time.
Appreciate that. Thank you very much. Is there anyone else here who'd like to speak to this body? Please. No, you're good.
I don't, is it working okay?
Yeah.
Okay. So I apologize. I'm not a public speaker, just a rancher. I like to thank the board for letting me have the opportunity to speak in front of you. I'm here today. I'm a rancher in Alexander Valley. I'm 83 years old. Just become wheelchair bound the last couple of months. I have had trouble walking. I have muscular dystrophy. The wheelchair is not a sympathy act to get any attention. It's what I am. But I'm afraid to say that what's about to happen is it's probably the most severe, damaging thing that could be done to ranchers in Mendocino County, Potter Valley, Alexander Valley, all the way down the line. The truth of the matter is, all the West Coast streams are having declining on salmon population, with dams and without dams. But taking this dam out is the most ridiculous thing. We're going to regret it in the future. We need water storage. We don't need reduced dams. I'm sympathetic to the fact of fish. I love fish. I love the steelhead fish, but what we're about to do is going to cost millions of dollars, destroy millions of lives. On dry years, it's going to be disastrous for farmers and public alike. And the general population doesn't really realize what the hell's about to happen. So I have a plan, and what I want to tell you today, maybe it'll have some impact. I know the minds have been already set up to do all this stuff, but my idea is to preserve Scott Dam for the time being, leave Van Arsdale Dam in. The most recent thing we hear about is the fish ladder is inadequate. I've, as a teenager, watched the fish go up the fish ladder on a Sunday with a bunch of friends, and we love doing that. The fish ladder, the first thing I would do is improve the fish ladder. If it had to be covered with a steel dome and some lights put inside it, I don't think fish need to have lights. They travel at nighttime. That would keep the debris from getting in the ladder. The dam is in place, and we have a water diversion system in place already. To spend millions of dollars to take Van Arsdale out, put rocks in there, 7 acres of boulders to try to make a fish passage, the ladder will work. It will always has worked. It will continue working. The fact that the only place we have a fish counting station, and it used to be an egg taking station, is at Van Arsdale. They took the fish ladder out at Benbow Dam. The environmentalists said it was inadequate. Fish couldn't get up it. Anyhow, so we don't know what's happening on the whole Eel River. The whole system is going down, not because of a dam on the smallest. I need some water. The dam is only blocking about 3 or 4% of the spawning territory above Scott Dam. It's loaded with pike mineral. The pike minerals are in the main fork, and Rice Fork and Bear Creek, and the dam is loaded with them. When they release that dam, they're going to deal. The whole system is going to deal with pike minerals, and these are small fish. They're big fish. So that's silt. It's either going to have to be all taken out, it's going to cost millions of dollars, or it's going to move downstream and destroy that 12-mile stretch of water that's above Van Arsdale. We realize that there is a problem on taking water on dry years, but with the existing system that PG&E has in place, which costs millions of dollars to improve a fish screening device, it's already in place. If you want to restrict the water in dry years, so be it. We understand that. But we have the capability, but that, I'm sorry.
If you could wrap it up, that'd be great. Thank you.
We have the capability of taking vast amounts of water into Potter Valley, the Eel-Russian River, on the wet years, and not a little pumping station that's going to give us a trickle of water. We can keep Lake Mendocino filled with that system, and that's been millions of dollars. So common sense tells me the other thing I would suggest to do is put a small hatchery at the bottom of Scott Dam, use native salmon eggs, if the salmon population is the one they're after, out of Willets. They have an egg tasting place there. There'll be native fish. They could take those fish, eggs, hatch them in the hatchery, small hatchery below Scott Dam. That will supply a salmon run all the way up, back up, and it will supply more fish in the river.
Thank you.
Thank you very much for the opportunity.
Yeah, no, thank you. Appreciate that. Is there anyone else present that would like to speak to this body? If you'd like to speak, come on up to the microphone. Well, actually, I think we're recording and whatnot. We want to make sure we have it in the record. And if you can keep it to about 3 minutes, that would be great.
All right, can you hear me now?
Yes.
How do I get this a little? I broke my neck, and so it's hard for me to get a little bit forward here. But I've got 3 different major points, all right? Number 1, the salmon industry was destroyed by the Japs in 1990. They put a 3,700-mile net across the North Pacific, and they wiped out the whole salmon industry. If you go to Canada, you'll find out that the Canadian government bought up every one of their licenses because they were at fault by letting the Japs in there. They put a 3,700-mile net across there. The only reason we got any salmon left is because the net was 200 miles off the coast of Alaska, and Alaska still has some salmon. So I fished commercially Prince William Sound in the 70s. I fished Bodega Bay 2 years in the 90s, okay? I know what I'm talking about. Down at Bodega Bay, the fishing game would come up and check our boats, which couldn't catch anything under 16 inches. And they'd let the Korean boats, the Russian boats, and the Jap boats take everything in the damn water and never touch them, okay? To try to save our salmon now is about 40 years too late, 30 years too late, all right? The salmon should have been protected back then, not now. There aren't any mamas and daddies to deliver any more eggs. If you're really worried about the salmon, put some hatcheries in and put some fish ladders up and down all of these rivers. You might save a few, but they're all gone, fellas. Might as well forget it. Every damn boat on the West Coast is up for sale. Okay, the next thing is that let's talk about Lake Pillsbury. The only way we're going to solve any problems for Lake Pillsbury is not by taking the dam out. First place, it's going to cost you hundreds of millions of dollars to take it out. 5 years later, you'll be trying to build a new dam because you'll be flooding out the little villages down on the Russian River and up on the Humboldt Bay. In the 60s and 65, or 64, I mean, we flooded out half of those villages because we had a heavy wet winter, and guess what? They couldn't close the gates up at Pillsbury, all right? So as far as trying to save those salmon by tearing that dam out, that's plain asinine. The next thing is that we need to talk about Pillsbury. If you're not going to do anything else with it, give it to the Indians on condition that they continue to maintain it. Let them build. They're the only ones that can do anything. Let them put in some campgrounds and housing and resorts up there. And they'll all be making money up there. and they won't pull that dam. They won't be agitating to pull the dam out, I guarantee you. If you pull that dam out, it's going to cost you hundreds of billions of dollars to replace it. If you think you want to pull the dam out and see how much water it goes by, open the gates and let it flood the whole damn place. You don't need to pull the dam out. Okay?
If you could wrap it up, please.
The next thing is that the whole, you know, not my grandfather, but many of you guys' grandparents built those dams. They built them at a time when they knew what they were doing. We don't know what the hell we're doing today. We sit around here and talk about pulling them out, you're crazy. Absolutely crazy. And we ought to start trying to do a few other things, all right? I think we ought to mobilize a militia, and as soon as they start bringing in
All right, thank
machinery
you.
to pull the dams out, we destroy the
Thank you.
machines, okay? Thank you.
Is there anyone else who would like to speak to this body? Please step up. And if you can give your name, that'd be great.
I will. My name is Bruce McLennan. I'm a Potter Valley resident. Been there over 40 years now. So I have a vested interest. I live right on the Russian River, so I would be losing water. I'm just going to make 4 quick points, and then I'll be out of your hair. Number 1, as Ed so nicely said, the salmon industry was ruined a long time ago. I have been at the fish ladder, and there are very few wild salmon coming up that fish ladder. We can put a fish ladder into Lake Pillsbury also if they want to use that particular watershed. We talk about green energy. We talk about electricity. There are actually 3 hydroelectric plants below Van Arsdale Dam in Potter Valley. There's not just one. PG&E has the big one, but there are also 2 other ones. So we would be cutting out hydroelectric power also, which is necessary. Third point, water storage. We need water. I have been here long enough now to realize that there comes times when we have low water in the winter months. We have not had it in the last couple years, but we have low water. The water from Lake Pillsbury and Van Arsdale, where it's put into the Russian River, we know that it goes all the way down below Santa Rosa. We're not just affecting just a short area, we're affecting a large area. Last point. Oregon, they decided that they were going to take and pull out some dams. They did. And they just destroyed the habitat. It's going to take years and years and years to come back, if it ever comes back. I don't want to see us make that same mistake. Okay?
Thank you. And anyone else like to speak to this body? Seeing no hands rise, seeing no bodies rise. I will ask those first 3 if you would like to please give your name to Candace so that we could have your name on the record as well as your comments. Appreciate that. That was a request from some folks. And with that, we'll move on to item number 4 on our agenda, which is the consent calendar. The consent calendar today consists of 1 item, and that is the approval of the minutes from our first meeting held on January 31st, 2024. And I'll look to my colleagues for any questions, comments, or concerns on that approval of the minutes, or the minutes on the consent calendar. And if I hear none, I would love a motion to approve.
I move to approve.
And a second.
I'll second. Thank you.
We have a motion and a second, and this one, I think, on the consent, public comment. We'll take public comment on, if you have any public comment directly on the approval of the minutes, now's your time to speak. Seeing no one rise, bring it back and ask for all those in favor of approval of the consent calendar today, which is item 4A, please say aye.
Aye.
Aye. Is there any opposition? Hearing no opposition, that does pass on a 4-0-1 vote. Thank you very much. Moving on then to item number 5, which is a topic of briefings and updates. Item 5A is actions taken since our previous meeting, the one on January 31st, on our Conflict of Interest Code, Registry of Public Agencies, and Notice of Joint Power Agency, the birthing of this agency, more or less. And I'm going to turn to Scott Shapiro to give us a verbal update.
Thank you, Mr. Chair. A very brief update. I'm Scott Shapiro, act as special counsel for Mendocino County Inland Water and Power Commission, and along with Corey O'Donnell, act as co-counsel for this agency. Just to report that the Conflict of Interest Code draft was submitted to the Fair Political Practices Commission. I believe they have about 3 or 4 months to respond, and we will keep you updated on their response and whether it requires any changes to the code. And both the Registry of Public Agencies and Notice of Joint Powers Agency have been submitted to the proper state agencies. That's really all I have on 5A, and I think that would take us to 5B, which I think Pam is going to lead off on.
Great. Pam Jean from the Sonoma Water Agency is going to speak to us on the discussions with PG&E, or Pacific Gas and Electric, regarding the Pardo Valley project.
Yeah.
Pam?
Thank you, Mr. Chair. So since the last meeting of this board, the new Eel-Russian River facility proponents, so that's the 7 agencies and non-governmental organizations that are meeting and provided a proposal to PG&E last November, they've had communications and met with PG&E. So PG&E informed the proponents at that meeting that it would not include the proposed facility itself in the surrender application that they intend to file with FERC, but that they remain committed to working with the proponents and continue to be committed to supporting efforts for the proponents to permit, construct, and operate a new Eel-Russian facility. So they also indicated to us that they would include portions of our proposal, that do not delay removal of the dams in the PG&E surrender application. So in other words, if there's work that can be jointly done and or done in parallel with PG&E that doesn't cause any sort of delay in their project, they would include it in their license surrender application. The 7 proponents have continued to work together to develop a regulatory framework that would allow for coordinating with PG&E to ensure that demolition and construction occur in a combined manner. So as PG&E removes facilities, there would be a coordination with them in order to construct the new diversion facility. And we are working on how to do that, and we're able, hopefully, to brief you on that in future meetings. But we haven't quite worked out the details yet of that. So that's really the extent of my update, and I'm happy to answer any questions if there are any.
Great. Thank you very much, Pam. I appreciate that. Director McCourty?
So please help me understand what they said about including us again in their decommission plan. Is that essentially what they said?
So the initial proposal to PG&E was that they actually include construction of a new Eel-Russian facility in their license surrender application. Mm-hmm. At first, PG&E never really responded to that until fairly recently, that part of the proposal. And so we were proceeding on as though they were going to include that in their license surrender application, but they did let us know in February that that they were not going to include the construction in their license application, but that they would continue to support coordinated efforts with them because they realized that construction would have to take place not necessarily in the exact footprint of their facilities, but at least very close to, very next to their facilities. So although they're not going to include construction in their license surrender application, they are going to include those things that we need to coordinate and be able to do, hopefully in parallel with them as they go through their license surrender application process and try to get an order from FERC. So, so they're indicating that they're supportive of the construction and the whole process that we need to go through to put a new facility in place, but it's just not going to be included in their application to FERC.
So theoretically, that would include like construction of cofferdams that could be used jointly by,
Exactly. That's exactly the kind of thing. So if you think about the project site at Cape Horn Dam right now, whether you're building something new or taking the dam down, you need to isolate the area, right? Dewater it, get the water out of your way so you can get equipment in there and do work. So since both projects, whether it's removal or construction, require that sort of dewatering, that's the kind of thing we expect we would coordinate on with PG&E. So it's exactly, that's a really good example of that coordination. There's more than that, but that's a really good example.
okay, thank you.
Director Russ?
Okay, I think I got it now. Thank you. My only question is, so that was at that point in time, that's PG&E's stance, that they had agreed to that. Have they indicated any change of their mind since then to date?
I don't think they've said anything different than what they said to us when we did meet with them, but they have clarified that. So I don't know if everybody saw like the letter to the editor that was in the Press Democrat. I think they tried to make it clearer to folks that although they're not going to include the project, which is what they indicated in their draft document that came out last fall, certainly since that document came out and when they talked to us in February, their stance changed. But since early February, it hasn't changed. They have tried to clarify for folks, including ourselves, exactly what they meant. But I don't, at least to date, they haven't changed their stance.
So that's the reason I'm asking, because PG&E seems to change their mind quite often, and sometimes it could be very quickly. They can do a 180-degree turn. So I just wanted to know if we're still on the same page at this point in time.
At this point, as far as I know.
All right, thank you.
I do have just follow up on Director Cordy's question regarding, I understand the coordination in the coffer dam and that whole piece, but could there be, as the design advances, both on, well, PG&E's design advances as well, if it's the demolition plan in total, that the benefit to PG&E by adjusting limits to their work would be, could that be something that FERC would bring up? Seems highly, that coordination that could extend beyond just being good work partners side by side, but the work,
The volume of the work,
the volume of the work
right?
would be adjusted, and of course there's an environmental document that describes the volume of that work, and it would be adjusted. Is there a possibility, I guess is what I'm asking, that this could be re-looked at? Would FERC opine about that, or would it be solely at the discretion of PG&E?
I honestly don't know. I'm looking at the attorney sitting over there. If he knows, I don't know.
I don't. Thank you for the question. I don't think we have clarity on that. It certainly is the case that public comment in the FERC process could drive FERC to vary from PG&E's application, but the extent to which it could vary is something that I don't think we could answer for you.
Okay, I appreciate that. It's honest. Well, I appreciate that. And any other questions from the board on 5B? We'll move on to 5C, and I will take public comment on 5A through C at the conclusion of item 5. This is an update on the grant application to the United States Bureau of Reclamation, and David Manning. Please, Dave, take it away.
Great. Thank you, Director Rabbit. I'm David Manning, Environmental Resources Manager for Sonoma Water. So the next phases of the project that we'll be describing to you, the alternatives of the project today, involve another level of engineering design. So the work that you're going to see us present in a few moments is to the approximately 30% level of engineering design. There's a grant program that's new as of this year from the U.S. Bureau of Reclamation called their Aquatic Ecosystem Restoration Grant Program. Sonoma Water made an application last year to that program and was awarded a grant for taking the design currently from 30% to 60%. We were awarded that grant in December. We are right now in discussions with technical staff at USBR to write the scope of work to award that grant to us by entering into an agreement. And that agreement, we believe, should be accomplished by May. After we have signed an agreement, Sonoma Water will start the process of soliciting for a contractor, putting out a request for proposals for that design work. The work itself is going to take about 2.5 years. So we'll be updating you as the grant is implemented and the designs progress from their current state forward to 60%. So it's very good news. The award was for $2 million of federal money. It's a 65% federal and 35% local cost share in this program. And there are, I will mention, multiple components of the program. This is the Part A, which is for planning, ecosystem restoration and fish patches projects. There is a Part B that is for the implementation of those kinds of projects. So we received this grant award for the Part A piece.
Great, wonderful news, and I just want to say thank you very much. Thank you to the staff for advocating for that particular grant in the first place, but then also being successful going forward. And I think what's true, while this is for Part A, if you get planning dollars, hopefully the implementation or the construction dollars will follow, since the government at that point has an investment in the program. So that's great news, and thank you for that good work. And I'll look to my colleagues. Any other questions, comments, or concerns? Hearing none. I will, since we're through with the briefings and updates, I'll look again to the public and see if anyone would like to opine on those last 3 items that we heard, which is really the Conflict of Interest Code, Registry of Public Agencies, Notice of Joint Powers Agency, or the discussions with PG&E, and or this last item on the grant application. We will talk about the facilities alternative selection here, the next item. Seeing no one rise, I'll bring it back to the board, and these are just to be accepted by the board, and I think we do appreciate all the staff work behind it. We'll move on then to items 6, which are our new business items, and really the biggest, the reason we're truly here today is to talk about this selection of facilities alternative for the transmittal or to PG&E as information for its license surrender application for the Potter Valley project. And I believe David's going to pull up a PowerPoint and lead us through this, as well as Tom Johnson and Grant Davis as well.
Director Abbott, thank you again. I believe I'm now connected to the audio. So as you mentioned, I'm joined here by Tom Johnson, a consulting engineer for Mendocino County IWPC, and we're going to share with the board the work of a technical advisory group that considered the fish passage and water supply alternatives for the new Eel-Russian River facility. In today's presentation, we'll talk about this technical advisory group process, some renderings, so we have some accurate artist depictions of the 2 alternatives. The first we're calling E2 is the pump station. The second, E3, is something called a roughened channel, and we'll describe that. We'll talk about the criteria we use to evaluate both of those alternatives and the scoring results from this technical advisory group, the preferred alternative, and our next steps. So the technical advisory group met 10 times from July 2023 to March 2024. It's comprised of biologists, engineers, water managers from 10 different organizations, including resource agencies like the California Department of Fish and Wildlife, the Round Valley Indian tribes, and non-governmental organizations like California Trout. So what the group considered was the change from the current conditions. So this is an example, and we'll show several for each of the alternatives, and the current conditions of a rendering that was produced by a consultant that we hired to generate 3D graphics that are very accurate. So this is based on engineering schematics and topography from the site itself. This is idealized view of the current condition of Cape Horn Dam. You can see some key features in this image. You see the face of the dam, that sort of stair-step appearance. Below it is something called an exclusion barrier that allows fish to not swim up to the face of that dam, but instead enter the fish ladder that you can see crawling around the outside of the facility here and entering back up into Van Arsdale Reservoir. In the background, the structure that you see is the entrance to the diversion itself, to the Van Arsdale diversion that carries water from the Eel to the Russian River. Here's that same image, again, an aerial perspective. And we'll be switching when we look at these two alternatives between a couple of different views and different levels of stream flow to show you what the conditions might be like with an alternative to this current dam in place. I will mention, as we take a look at the current facilities, that the disposition of the dams, so Cape Horn Dam, Scott Dam, are sort of not the purview of this investigation, of these discussions among this technical advisory group. That lies squarely with Pacific Gas and Electric and with their decommissioning plan. So we did not consider the fate of the two dams, especially Cape Horn Dam. We're only dealing with how to pass fish through the site and maintain a diversion between the Eel and the Russian River. The ultimate disposition of the dam itself is something that will be deliberated in PG&E's decommissioning plan. So if we're looking downstream, we can see Van Arsdale Reservoir. If we take a look at the first alternative, what we're calling E2, the pump station, the most obvious change is the absence of the dam face in the image. Here in the center of the image, instead you see a green building with a brown roof. That is a pump house. We'll show you what that pump house is drawing water from as we take a look at view of the river at lower flow. This is what the facility might look like with thousands of cubic feet per second in the river. The area that you see of land adjacent and just upstream of that green building is new ground that is covering over a conduit that takes water that is pumped from the river at that location upstream to a newly configured diversion. So the water is entering the tunnel in the same way, but it is being mechanically lifted from the river upstream to the tunnel location. There is effectively nothing in the way of the fish and the river as it passes by that site. And you can see that a little bit better when we take a look at an image that has lower flow. So that previous image was thousands of cubic feet per second. This is hundreds of cubic feet per second. You can see some other features begin to emerge. We'll start at the downstream direction. You can see the faint outline of a concrete structure. That's that former exclusion barrier. If we go upstream, that's the former foundation, the base of the face of the dam, reduced only to a small concrete sill. At that green building, you can see what looks like a cage at the water surface. That cage is protecting the screens themselves from debris as it floats downstream. Here's another perspective, again at a higher level of flow. Looking back upstream, you can see those same two structures causing a small bump in the river. That fish would need to ascend, but there really isn't much of a challenge for fish to swim past this site. Let's take all the water out of the river, which is a condition we hope to never see in the Eel River, but this reveals some of the features that underlie this design, this pump station design. You can get a much better view of those cages that have the screens, the remnant pieces of the dam left in the channel, really just to help to control the grade and stabilize the site. It's shown here, the old fish ladder is shown, but it can certainly be removed. It's shown as filled with concrete. It is out of service. The only way fish are getting upstream through the pump station is directly up the river channel itself. If we look at a downstream perspective, sort of a fisheyes view coming downstream, you'll see the river is really unconstrained with the exception of what's going on the left riverbank. The channel will evolve naturally as time progresses after the removal of Scott Dam and the removal of Cape Horn Dam itself. And if we look down the valley, we can see this actually depicts the river at a relatively low level of flow. And we'll see that again in images that show the roughened channel alternative. An aerial perspective, just to orient you, again here the total amount of flow in the river, relatively low. The artist's depiction of what's happening upstream is really an educated guess. So if we look on the right-hand side of this image and we see that what looks like a pool of water, that's probably a very shallow, slow-moving section of water. the extent of which is nothing close to what exists now with the current Van Arsdale reservoir at that location. So if we switch over to the next alternative, the Ruffin Channel, we're looking upstream. And what we see here in this perspective is the absence of that pump house, because the water is currently, in this alternative, diverted upstream at the existing Van Arsdale diversion. And we'll show you what the screens look like in that location. But the idea here is to build a channel that allows fish to ascend upstream to a point at which the water is slightly impounded near that Van Arsdale diversion and allows gravity to feed the tunnel and the diversion between the Eel and the Russian River. So there is no mechanical pumping. There is instead this engineered boulder cascade. So there's a lot of rock fill in these images, and that becomes more clear when we take some of the flow out. So same relative amounts of flow as in the previous image. That previous image was thousands of CFS. I'm sorry, as the previous alternative, this is hundreds of CFS. And you can see the boulders in these images. These are all either quarried directly on the site or brought to the site, very deliberately placed. And the way the boulders, their location was determined was by looking at reference conditions in the main stem Eel River around the site to see where large boulders would naturally fall in the channel and how fish can successfully navigate those reference conditions. So all the geometry in these images is very accurate and true to the designs that our consultant developed. Here's that same site without water. So what looks like a natural river channel is engineered, but it serves the purpose of allowing the depth and the velocity as water flows in and amongst those rocks to pass adult salmon and steelhead and lamprey upstream and juvenile fish downstream on their migration to the ocean. Another perspective, an aerial view. It doesn't look like there's a lot that's designed and constructed in these images, but there is a lot of advanced design and consideration of the hydraulics of the site that are involved in designing something like the Ruffin Channel. Again, the same image with with lower flow. Looking downstream, you can get a sense of the slope that's involved in the development of a channel like this. It is steeper than the surrounding terrain. So the Ruffin Channel is at a 3% slope. It's 800 feet long, and some of these boulders that you see for scale are as large as 12 feet in diameter. There is a lot of rock in this Ruffin Channel that's 4 to 9 feet in diameter, a tremendous amount of rock to build up this channel to get the water to the existing elevation of the diversion. So looking at the diversion facility itself, it would be reconfigured. This is the way it would look at high flow. And this image that shows a bit of an impoundment upstream is more accurate than the rendering that you saw for the pump station alternative. If we take all the water out, you can now see the screens. No mechanical pumping, these are screens. They would be cleaned mechanically, but they allow water to flow via gravity down into the tunnel that exists currently. So a very different concept. And those two concepts were passed through a series of evaluation criteria. There's a lot of information on these slides. I know this presentation will be posted after the meeting. Certainly don't expect everyone here today to read all this fine print, but there are both biological criteria for upstream and downstream passage, as well as several other factors of these potential facility designs that we'll be describing to you and briefly giving a summary of some of the results. So some of those biological feasibility criteria included how fish would pass under high flow and low flow conditions, how much energy they might expend, whether they're delayed, whether they're injured, if predators can take advantage of the fish differentially between the two alternatives. We looked at the resiliency and the reliability of the two facilities. How do they respond to sedimentation, both in the short and the long term? How stable are they after large floods? Looking at that through the lens of water supply as well as fish passage. How vulnerable are they to other natural hazards, flood, fire, seismic? look at the constructability and the cost. So how complex are the designs? We mentioned earlier dewatering and cofferdams to build the facility. What would it take to build it? And then what would it take not only to build it, but to operate it and maintain it and replace some of the equipment? So the results, this group, this technical advisory group, comprised of about 30 members from 10 different organizations. Each organization got together with their experts, their biologists and engineers, and ranked on a scale from 1 to 10, with the higher scores being more favorable, how each of these criteria would apply to both alternatives. In this example here, you can see the biological criteria, in this case for upstream fish passage, were applied not only just to the two facilities, but how each life stage of the most sort of critical species, steelhead, Chinook salmon, lamprey, would respond to the design and the information that our engineers developed. We looked at that for, of course, both alternatives. You notice a difference in the colors here. The greener end of the spectrum would be higher performing potential criteria for upstream passage. The warmer redder colors are less scored more poorly than some of the other criteria. And we compared side by side the two alternatives by averaging all of these scores from each organization and also considering their range. And I'll talk about that in just a moment. But one thing to note, and all these results will be presented in a final report that's forthcoming, not every organization had expertise in every category, so not every organization scored all the category. And you can see in the results that column that's labeled fraction of scorer participation, that's indicative of the number of organizations that participated in the scoring. Most organizations participated in the scoring. And if we look at how the scores varied across the various organizations and the scores, we look at the range, which is the difference between the highest and the lowest score in a particular category. The higher the range, the greater potential uncertainty in an item and the less agreement among the scorers. So it gave us a place to focus and try to resolve why there were open questions about some elements of the design. And in some cases, it's just a reflection of how far the designs have progressed. There is lots more information that will be gathered as we move farther into the design process. And there are some uncertainties that may or may not be resolvable with the level of detail that's already been provided. So with that, I'm going to turn the presentation over to my colleague, Tom Johnson, who's going to talk about some of the high-level takeaways from these 38 categories and how we reached our decision. So Tom.
All right. Thank you, David. Tom Johnson. I'm an engineer with an extensive background in hydroelectric and water project operations for 35 or so years, and been working on this for a number of years for IWPC. One thing to remember in looking at these alternatives is the 30% design report that went into this. So that was funded by a DWR grant. McMillan Jacobs is a well-regarded engineering firm that's been working on this for about 18 months and has compiled a very extensive body of work. I think we're at 450 pages and growing virtually by the day. That report will be made available publicly. I think we are probably 4 to 6 weeks away from a final version, but you will have access to that. I've been through it a couple of times, and I can assure you it is dense. There is a lot of information there. In addition to that, David mentioned the technical advisory group, which consisted of biological experts, engineering experts, a number of resource agencies and so forth, and everyone was charged with reviewing the report, bringing their professional knowledge and background to that review, and then ranking, as David has just walked through the scoring matrix. There were 38 different categories to be ranked. Everyone needed to do that using a combination of professional judgment and relying heavily on the report that was produced. And so in the compiling of the rankings, you saw some of the heat maps that David showed earlier. we're trying to get our arms around how to compare everything different ways. And when you get 25 or 28 experts in a room, ask them to rank something, of course you get somewhere in the order of 25 or 28 different opinions on this, that, or the other. But it was very clear from early on in our discussions about the ranking that there were some themes that were fairly unassailable. And this final graphic, I think, highlights those pretty eloquently. So everything that's in green basically wins. And I use that term sort of flippantly, but you know, the rankings were generally close. Both of the alternatives that were developed were intended to achieve exactly what these structures were intended to achieve: fish passage, water diversion, reliability in the face of sedimentation, operational effectiveness, and so forth. So if these alternatives were going to be failing, they would have gone by the wayside much earlier. So we tended to get scores of 5.5 versus 7.5. This wasn't a 1 versus 10 or a 8 versus 2. It was much, much closer than that, which reflected the quality of the designs. But I will say again that it was consistent. So the first block of scores here is upstream passage. You can see that those all favored the pump station. There's a number of reasons for that, and once again, if we brought 6 or 8 of our biologists forward, I'm sure they would all have opinions about what was most important. In general, the roughened channel was quite a bit steeper and had higher velocities. That tended to count against things like energy expenditure and the ability to pass at different flow velocities. So generally, the pump station scored a little bit better. For downstream passage, there was virtually no difference. There were some numerical differences, but by and large, it wasn't considered a deciding factor. Both of the designs would allow downstream passage fairly effectively. For resiliency and reliability, you can see that fish passage, natural hazards, both scored slightly better for the pump station. For mechanical systems, that scored better for the roughened channel. Not much of a surprise there. More pumps, more moving parts, more things to go wrong, and so a higher score for the roughened channel. For constructability and implementation, design complexity, which we'll come back to in just a moment or two, site access, subsurface condition, and materials, all were generally favorable to the pump station. So if you get 28 people scoring this and you ask them each to summarize their findings, once again, you'd get 28 different opinions. And so in listening to the 6 hours of discussions amongst this technical panel, trying to come to a conclusion, there were a few key takeaways that I'd just like to spend a moment or two on. The fish passage was fairly clearly better with the pump station alternative. That was a fairly universal feeling amongst all of the biologists. It was just superior because of the lower gradient, less energy that needed to be dissipated by the channel itself. Didn't necessarily have big 12 and 14-foot boulders with water crashing about. Although E3 might have been able to be designed to be close to that at some point in the future, all in, the pump station was always going to be a better fish passage alternative. Under sedimentation, and this got us into a fair amount of the hydraulic modeling, velocities, and so forth. In general, the risk of aggradation, which is sediment accumulating in the vicinity of the diversion facility. If you think about the roughened channel and the fact that there's lots of big rocks sticking out, the potential for it to trap more debris as it came down, back up, and then make fish passage hydraulics potentially even worse was higher. And so again, advantage to the pump station versus to the rough-in channel. For construction costs, both of these alternatives were very close in the first blush, but as David mentioned, the placement of the rocks in the rough-in channel were very precise on the renderings. And the reason for that is it would take very extensive hydraulic modeling beyond what was done in this first phase of design in order to place those rocks in a way that they would be both dissipate the energy but still allow fish passage. And that would have been, the hydraulic modeling alone would have been quite a lift in order to design this facility with precision and to make sure that it would achieve all of its objectives. Similarly, without having the benefit of geotechnical analysis, which we don't, haven't had access to the site, haven't had funding for that portion of the study yet, the potential for subsurface conditions not favoring the rough-in channel were pretty high. And so almost all of the engineers who looked at this, civil engineers from the water agencies and from the fisheries agencies, were pretty convinced that the risk of the construction cost being far higher with the rough-in channel was very high. And that was, you all are public agencies, you're risk averse, and that sort of a risk is to be avoided. On the operations and maintenance cost, as you might suspect, the pump station with its more mechanical features, the cost of electricity, even though it's not a big lift, I think it's only in the 30 to 40 foot range to lift the water from the river up into the tunnel. It's still a cost, and it would accrue to every drop of water, maintaining all of those mechanical pumps and so forth. It definitely would have been an advantage to the rough-in channel, but at the end of the day, that was the only category that was an advantage to the rough-in channel. Under constructability, as I mentioned earlier, the depth of design, the complexity of design, and the difficulty to implement that would have been fairly high. 800 feet long, 3% grade, the grade would have to be precise. The rocks would literally be placed individually and very specifically with GPS or survey data, right? The pump station, while it is a complicated object, it's a pump station. You all are water agencies. You all know how pump stations work. You've built many. It's a known technology. It's relatively, it's going to be easier in a lot of ways in constructability and implementation. And again, this was a fairly consistent belief amongst all of the engineering staff. And then just to mention it, there were a lot of factors that were close. I mentioned downstream passage in the previous slide. There were a number of other things, geomorphic stability, the ability of these different alternatives to divert water, challenges in integrating with PG&E and us working with them on the same site at the same time. All of those things were probably going to be fairly equal between these alternatives. And so they were really non-differentiators. They didn't help us select. At the end of the day, the E2 was selected as by the technical advisory group. It was brought forward to the steering committee, which is basically the managers of all those technical folks. And the E2 is brought forward as the lower risk alternative and a superior alternative for fish passage. It's got lower design and construction risk. There's clearly superior upstream and downstream passage, and probably a better ability to design around potential reliability issues. In other words, what I mean by that is this thing needs to work come high water and higher water, which certainly can occur in the Eel River, and we collectively felt that the pump station would allow more opportunity to be built in a way that it simply would not fail no matter what. So that's the recommendation that we have for you today. I think we'll take any questions at some point in time, and Grant, over to you, I think.
Thanks, Tom and David. Very briefly, I'm here as representative of the project proponents, the steering committee. We meet fairly regularly, almost once a week, and we heard in great detail from the TAG and came to the recommendation that we have today. So the TAG through the steering committee ended up, Tom, could you go back one slide, please? I'd like to keep the, if you can. Yeah, that highlighted section there, I think, is the defining piece for those of us that have been involved. I want to thank all those that have been participating. Janet, I know you're part of these. Charlie Snyder, some of you in the audience are part of these calls, but that's the statement. The E2, which is the pump back facility, is the lower risk alternative for water supply, and it's superior alternative for fish passage. And that was the overall message that the steering committee wanted me to deliver on behalf of that group to you today as you deliberate on that decision. So there is a unanimous decision from the TAG as well as the steering committee on the pump back solution, and that's what we're recommending this afternoon.
Much appreciated, and I want to echo those thanks to everyone who participated in those 10 meetings and probably countless other calls and assemblies to come up with the criteria and then to grade that criteria and to make the recommendation. And thank you also for being very inclusive in who you brought into that. I think anytime you're embarking on a new project, it's important to bring in those that may even be critical of the project to participate to have the best outcomes going forward. So I do appreciate that very much, and look forward to the discussion here by this body. And I'll look to my colleagues for questions first, perhaps, and then we'll go comments, and we'll certainly go to the public comment as well.
Mr. Chair, if it would be appropriate, we do have a slide, if you go to the next one, David, which is a recommendation that perhaps will help the board and the public focus their attention.
Right. Appreciate that. As much as I love gravity, I am totally swayed by the presentation and the experts that have opined thus far. And I'll look to my colleagues for any questions, comments, concerns. Director McCourty?
Well, thank you for the presentation. Obviously, lots of work and thought have gone into it, and I'm not going to second guess the TAG. I certainly don't have the expertise. The issue for me remains the energy piece and what it's going to cost. And I did some quick calcs, and I don't know if I'm right, but if what I understand is that we're going to need about 1,000 horsepower of electricity to move the water. Is that correct?
So I think that's the right ballpark. I don't know if it's exactly 1,000.
Mm-hmm. So me and Google researched it real quickly last night just to see what that looks like. So it comes out to be about a megawatt, basically, of power to operate this. And just for reference, the Potter Valley project generates about a little over 9 megawatts. So, you know, the power could be close at hand, and I know that's not part of the question, but I would hope going forward, since we can't depend on gravity, it'd be nice if we had locally supplied electricity that could help us operate the project at a reasonable cost. But if I understand right, you're saying, I think Tom yesterday, there would be $5 to $10 an acre foot approximately for pumping this to get it into the tunnel.
Yeah, the cost estimate that's in the report that y'all will see is between $5 and $10 per acre foot for lifting the water into the tunnel.
Okay. So, again, too bad gravity doesn't work out, because that's, from a point of view of energy expenditure and carbon footprint, that's a really good way to go. But if it doesn't work, it doesn't work. You know, and I think that the idea of the roughing channel is really great, but what I was struck with is that there doesn't seem to be any really good examples of a roughing channel this size that we know is dependable. And I think dependability is a big issue when we probably have one shot at making this work. We're not going to want to have to redesign and rebuild it. And it sounds like pumping stations are a very known technology, whereas roughing channels are not. Yeah. So
yeah, there are examples of much shorter, smaller roughened channels, but this to our knowledge, would be the biggest attempted.
Yeah, and I'm just imagining the flows that sometimes come down the Eel River at 25,000 cubic feet per second is one hell of a hose to be hitting a landscape with, and it would take a very rugged channel to get that kind of water. And if we carefully place something and wanted it to stay carefully placed, I can only imagine what happens when all the various alluvium and rocks and things come down, what that does to anything in its path. So, and for that matter, just everything that remains from the Van Arsdale structure and the new structure that's being put in, will that be stable under those kind of circumstances? What does that look like relative to the position of the facilities on the landscape?
Yeah, and if the river, which it certainly will, rise to that level and were to rearrange some of those boulders that were so carefully placed, the risk there is that impediments could be created that are difficult to correct for fish passage. So, one of the primary objectives of the project is to ensure that the ecosystem is healthy in the Eel River and fish are able to pass upstream. Post some very large flood, there's a potential to create barriers in the fish passage facility itself if things get moved around to too great an extent.
Mm-hmm. Well, that just helps me make my mind up. Thank you.
Thank you. Looking to my Director Russ.
So one thing that was puzzling for me was that when you place the boulders that you're talking about, David, and you have the high waters, it seems like there's going to be a lot of movement in there. So are operational costs included with, restructuring that channel? I know it's not the recommendation, it's just a question I had on the presentation.
There was a consideration for the maintenance and the rehabilitation cost of the roughened channel involving, work in the channel itself to replace boulders and move them and the like. Yes.
So over time, if that recommendation or that style, the roughened channel, if that was selected, so that would be an ongoing problem that would have to be looked at annually, unless of course we had drought years like we've had for the last 30 years.
Yeah, I'll take that one. So that's what I alluded to when I mentioned the detailed hydraulic modeling that would be required.
Oh, okay.
We've undertaken a 1D model, which is fairly simplistic. It would have required at least a 2D and potentially a 3D model. If you have good enough modeling, you can design those boulders, either if they're big enough or if they're anchored properly, that they will not move, even in a 100-year storm. However, I wasn't kidding when I said the amount of modeling it would take to get that all just right and make sure that it would be robust was going to be really extensive. And that was part of the concern about the cost growing with the roughened channel, is that you would have a lot of those sorts of challenges. We know they're there and we're sure they can be solved, but it would be difficult. This type of installation, these roughened channels, otherwise known as a nature-like fishway, are commonly used for bypass channels of existing structures and dams. I'm working on 2 of these on other river systems just now. However, they're very rarely used in the main river channel and in a river with as much energy as the Eel at this location. So typically it wouldn't take the full force of the river, it would take some smaller amount. Instead of a fish ladder, there would be this roughened channel, and then it can be designed very correctly to not need that sort of extensive maintenance. It's only taking a portion of the flow of the river. In this application, as David mentioned, it's a first of a kind of this size and this scale, and it would take a lot of proving out if we were to go that way.
So I think you just answered my other question. I must have missed that when David mentioned that, because what I was wondering was exactly what you just commented on, like how much, not only the cost and everything, but the other factors that you guys looked at with the roughened channel. So I think you just answered that question. The other thing I noticed on your matrix was that it included operational costs. But I'm wondering, was that factored in under the actual construction cost of the new facility?
Construction costs were absolutely considered between the two. And the construction costs, with some assumptions for both facilities, were fairly close. And Tom can elaborate on that maybe a little bit. There's more uncertainty, certainly, in the Rough and Channel's cost estimate. There's a very healthy contingency deliberately for both facilities in terms of its cost that can absorb some of the increases or decreases as later phases of the design progress. I don't know, Tom, if you want to add anything to that.
Yeah, in the cost estimating at this early stage of design, there's a cost estimate, and then it's got a band around it, right? Minus 30% plus 50%. That's a big band if you think about buying a car that this price, minus 30 plus. And so as we progress in the next phase of design, when we get to 60%, we would expect to be a minus 10 plus 20, right? We will have narrowed the uncertainty. We will have gotten closer to the final cost. By the time we get to construction specifications and eventually construction, we'll be very tight, right? But that's a couple of years and a lot of work in the future. So within the margin of error, these were both the same price, but it was pretty much a consensus of all of the engineering folks that looked at this. There was just so much more risk around the Rough and Channel and the potential for those costs to go much higher, that was a key concern for all of us.
So, yeah, I was really surprised to see that those costs were about the same, because I really thought, just if I had to guess, I would say the other costs would be 2 or 3 times as much. But as you guys showed, they're about the same cost. And there's much more risk with the Rough and Channel. So anyway, thank you for your presentation.
Director Pauly?
I was involved with these meetings a lot and read the 400-page document and learned a lot from biologists and from engineers. Some of the engineering comments were particularly interesting, and while we all agree that gravity doesn't break, and that's great for a diversion, gravity also doesn't necessarily help us with 20,000 cubic feet per second pushing boulders downhill at a 3% grade. So the chance of that structure, the way it is currently envisioned with only a 30% design, makes it riskier than what we worry about in terms of diversion. E2, the pump station, also seems to me to be less risky, and Tom, you can explain this a little bit more for folks. The sweeping velocity, the way that is designed with those screens on river left, where the water's hitting that wall and moving downstream, is going to help keep sediment and debris from collecting around those screens, much more so than they would in E3, is my understanding, which I think is important. And there's a redundancy in the numbers of pumps. There's actually 7 pumps that are envisioned here for this project, which gives us some alternatives if we were to have pump failure for whatever reason during diversion times. I think one of my other really big concerns was if the Rough and Channel were to fail in a severe storm event or a seismic event, or for whatever reason, it'd be extremely difficult to repair it during the winter in normal river flows. We probably wouldn't be able to get in there and access the area to repair it until very low flows, and we could lose not only fish passage for periods of time, but we would also lose our ability to divert water altogether. And you can tell me if that's not true. I'm saying it's a small risk, I understand, but a risk nonetheless. So I guess for those reasons, I mean, I was really pleased with the aesthetics of the Rough and Channel, I have to admit. Much friendlier looking riverine view as you come around that corner in a kayak. But with regard to risk and fish passage, E2 did rise to the top pretty clearly. And I'm hopeful that in the next round of design phase, that we will find a place where we might be able to reduce the cost of the pumping as well as we move forward. So correct me if I'm wrong on any of those things, Tom or David.
Nope, spot on.
Thank you, and I, again, just want to say thank you for the in-depth work, and I too, I don't, there's a show on TV about Drain the Oceans. Anyone seen that show? The graphics were great, and I do appreciate seeing the different flows and getting down to the nitty-gritty of the landscape beneath the channel. So thank you for that, and that was a good way to really put out there the impact of the projects. You can almost feel it. I have to imagine on the cost, again, just thinking about that, that band that you mentioned, which is I totally agree with, but really probably is even a little wider with a project such as the largest of its kind project with the Ruffin Channel, and as opposed to a known commodity, as you said, with a pump station, which is probably easier to hone in on the nitty-gritty on pricing, notwithstanding some of the site particulars of contingencies, which will get itself sorted out as we go. And I do agree that we continue to push that price and get us into that sweet spot to really try to make sure that we understand the implications of what $5 to $10 pumping cost per acre feet mean at the end of the day, based upon the acre feet that are moving through the diversion. I also appreciate the comment regarding the local source of renewable power, I would assume, with the appropriate backup, especially to take care of moving the water on those dates when we're going to be moving it, which may also coincide with dates where highly unlikely power shortages or outages. So really making sure that we're on top of those things there, I know would be front and center as well. So before we take action on this and move forward, perhaps if it's okay with my colleagues, we'll go ahead and take public comment. And this is really just talking about these two alternatives that are in front of us, whether it's the Ruffin Channel or the pump station, and see if anyone has any questions, comments, or concerns, or would like to address this body. Please, and if you could state your name, that would be wonderful. And yes, and if you could say 3 minutes,
Sure.
We'll try to give everyone be fair and equitable.
My name is Frank Lynch. An observation. The graphic showed high water and low water. We've experienced plentiful rain and drought. The Eel River may run dry. So was that considered? And then also, lastly, when you're defining how much you're going to be pumping, it was my understanding from early on that you were going to only pump during high flows. Have you defined what a high flow is? And do you have an idea of the range of days that would be in a typical year, if that can even be defined? Thank you.
Thank you. We'll consolidate all the questioning and see if staff can help us out at the end there. Anyone else like to speak to the body, please?
Thank you, Director Abbott. My name is Charlie Schneider. I'm with California Trout, and I was on the tag led by David Manning and by Tom. And I just want to give a big thank you to all the agencies and other tag members for being really generous with their time and their expertise over the last several months. I mean, we had 6-hour-long meetings to reach consensus on this. Working through the scoring matrix was, I think, really enlightening for all of us. I had a number of comments, and it was really interesting to hear most of them get brought up: aesthetics, cost of pumping, and sort of the ability to need to expend energy. I think these are all things that we're all of us that were on the tag have thought about a lot, and are certainly still concerned about as this project moves forward. So I want to thank you for your consideration, and I definitely want to encourage you to support the E2 alternative that the tag has brought forward to you. Thank you.
Great, thank you, and thank you for your participation. Please.
Good afternoon, Laura Garza. I'm the Water and Climate Change Advisor for Mendocino and Lake Counties. I'm just wondering if you could give us an example of a river that is using strategy number 2 and how is it held, and any of the benefits that you can provide for that example.
Great, thank you. Anyone else? Would you like to speak?
First of all, I'm sorry I didn't say my name. I'm David Finucci, Alexander Valley farmer, 83 years old. I know what the question is here. I'm supposed to comment on these two proposals. Why would you spend millions of dollars to do this when we have a system that would work with a better fish ladder? It makes absolutely no sense to me. The water would come through the tunnel, free flow, no power, no cost on so many dollars an acre foot. That's all I have to say. I do not understand it.
Thank you. Anyone else? Seeing no hands rise, seeing no bodies rise, we'll bring it back to this body and look to my colleagues. Any final questions, comments, or concerns? Actually, we'll turn to staff, and not sure if you were able to jot down a couple of those concerns, but I heard a first commenter talk about high flow and actual dates of diversion, and you can talk about that. Examples of other pumped diversion tunnels, and then why the fish ladder would be inappropriate or appropriate.
Thank you, Chair Rabbit. I'll take the first question, and I'll turn the second one over to Tom, and we can arm wrestle for who answers the third, perhaps. It's a very good question. The levels of flow in the Eel River are highly, highly variable, from extremely low to extremely high. It's a flashy river, much like the Russian River is a flashy river. That's the term we use for it. It's interesting, the criteria that we evaluated, they define based on guidance from the National Marine Fisheries Service, California Department of Fish and Wildlife. There is a level of flow on the high end to consider for fish passage and on the low end to consider for fish passage. That low flow for upstream moving fish is several hundred cubic feet per second. It was pointed out to us by our colleagues in the resource agencies that even though that's their criteria, fish migrate at much lower flow than that upstream in the Eel River. So we had a very good discussion about how the different alternatives would perform even under those much lower flow conditions. And it was felt that at very low flows, less than 60 or 70 cubic feet per second, for upstream migrating fish, some of the depths and some of the jumps and the hydraulics in something like the Ruffin Channel could be problematic for an upstream moving salmon. Even though that's not strictly by the letter of the criteria, that's the benefit of having all the experts together to think about how one of these alternatives would actually behave. On the very low flow side for juvenile fish, for younger fish, which is evaluated at a different time of the year, the flows in the Eel River can get very, very low. The low flows we evaluated were in the tens of cubic feet per second. At those very, very low flows, there are still open questions about whether there would be surface water in that Ruffin Channel. It's composed of many feet of layered rock, and the attempt to seal that rock would be a part of the construction process. But with all that potential porosity and the flows that low, there were concerns about how much water would be available for fish to move if they wanted to at even the very, very lowest flows. So the answer is yes. A wide range of flows were considered. In terms of the flows for diverting water, the idea is to take water from the Eel River when it wouldn't pose an ecological risk to fish in the Eel River. We're working now on what those diversion criteria would be. The concept is, of course, in the wintertime when the ability to store that water exists in Lake Mendocino would be to divert it rather safely when there are thousands of cubic feet per second in the Eel River. There are also needs for water supply in the spring and in the fall when there's far less water in the river, and those criteria are something we're working with the Round Valley Indian Tribes, California Department of Fish and Wildlife, National Marine Fisheries Service on determining. So the most likely approach would be an allowance of some percentage of the flow above a floor. So there would be an amount seasonally that would need to stay in the river to allow the fish to continue to migrate and other ecosystem services to be provided by the Eel River for all the biota in the Eel River. So that is something that's very carefully considered and will be the next phase of our work moving forward for the next piece of design. So for the second question about examples of these facilities, that's for Tom.
Yeah, I wasn't 100% sure if that was examples of pump stations, but those exist. The ones I can just think of right offhand and near where I live are on the American River and the Sacramento River in Sacramento. There are others on the Sacramento River further upstream. They're on the San Joaquin River in a number of locations. Various irrigation districts use these, and they're screened, so they are, you know, I don't know if they're fish friendly, but they're at least fish proof, so they don't pull the fish into the pumps. For the Ruffin Channel, I know there are two I'm familiar with that are in design right now. One on the Yuba River around Englebright Dam, and one on the San Joaquin River around Sac Dam. Those are both at some level of design right now. And then the Bureau of Reclamation has a couple of them. I don't remember the exact river up in Montana. And then there's another one on the Truckee River somewhere downstream of Reno. So they are out there, and if you do a Google search for Ruffin Channel Fishway, which I did recently, you'll find quite a few examples. They're fairly prevalent.
And I believe there was a third question. We have, Tom, did you jot that down?
Why are we taking out the dam? We could just use a fish ladder.
So the question, why remove the dams or why modify substantially Cape Horn Dam to remove it as opposed to construct a fish ladder? The decision to remove Cape Horn Dam again rests with PG&E. So PG&E made the determination that they would remove Cape Horn Dam and Scott Dam. The charge of the group that we assembled was to try to figure out a way to divert water without that dam in place. I will say, and I believe the very first meeting of this body, I presented some of the reasons why a fish ladder has been challenging to maintain at Cape Horn Dam. I think that was definitely prominent in the minds of the resource agencies that came to this technical advisory group. They wanted to see fish migrate through the river channel in some fashion other than needing to ascend a fishway. But fishways are most effective when there's something like a dam in place, and in this case, our challenge was to design something without a dam at that location.
I appreciate you responding to those comments, so thank you very much. With that, I'll bring it back to my colleagues, see if there's any last-minute questions, comments, or concerns, or if anyone is willing to make a motion to approve the selection of E2, which is the pump station, as this preferred alternative to move forward.
Two quick questions just to understand something. So no matter what power, we'll have redundant power for the pumping, correct? So that in the event of a power outage, which is likely to happen during high flows.
Yeah, there's hopefully already redundant power at that site, believe it or not. The PG&E line comes in from two directions, one over the hill from Potter Valley and the other one up from downriver. We have yet to investigate with PG&E to see if those are both feeds. In other words, there is a way for power to flow and get to that site from two directions already. So if one goes down, you still can have power. And then we would anticipate a backup generator with at least some number of hours or days of capacity to be located on site.
Okay, and then just to reiterate what I think I just heard was that the actual bracket of flow that would be allowed to divert water is not yet completely determined, right? It still needs further study.
Yeah, that is correct. That's a next assignment, or one of the next assignments for the TAG to work through that.
Okay, thank you.
And just so I know, and that determination, that number that you're going to come up, that range, is dependent upon the preferred design that's selected based upon geology and everything else, or is it strictly theoretical water flow?
Yeah, it'll
And
be,
dates.
it'll be just based, it's irrespective of design. And
Okay.
typically, what goes into a flow regime is consideration of hydrologic year type, wet, dry, somewhere in the middle. Seasonality, you might take different flows at different months of the year. Some kind of a minimum flow, some kind of a sharing of flow where you would split, you know, the river gets the first increment, the diversion gets a second increment. There's a lot of different ways to structure a flow regime, and there'll be a lot of, I'm sure, robust discussions around what that looks like.
And I know that we probably have talked about this in the past, but any rough idea of time frame to come up with that number? Because that obviously is so dependent upon costs and operation costs and amortizing those over the course of time.
I think my mic control's hidden by the Zoom, so I'll attempt to answer that. We're hoping to do that this calendar year. That's our objective. We have to assemble the tag. There's some technical work involved in evaluating that. So, but that's our objective.
Okay, appreciate that. Thank you.
And
Any
Mr.
other-
Chair, if I might just
Please.
note for the benefit of the board, a lot of gratitude to Sonoma for leading this particular effort, the work that's been underway, and then actually RVIT's consultant is going to be leading a lot of the work that's currently occurring on the flow issue. So our thanks to RVIT for doing that.
Great, appreciate that. Please.
Just a point of clarification. Just a point of clarification. So we talked a little bit about, and I think one of the questions was about the water diversion. So it's my understanding that those discussions will be happening, and probably right away, and will be leading to perhaps, for lack of a better term, some type of water diversion agreement that the TAG looks at, and then we'll evaluate that and see if that works for all parties involved.
Yeah, there's a lot of different ways there's a lot of steps to get to what you just described. So there would need to be the technical work to identify the flows that would be acceptable and enough water that comes across to be beneficial, but no negative impacts to the river. And then that all has to be codified in some way with agreement or agreements. And there's probably some regulatory water that gets sprinkled on it to make it pass muster with all the state and federal agencies. So all of that has to happen. We don't have a schedule for you, as David said. There's already work afoot to get started on that. Hopefully we could have great progress by later this year, because that is a burning question. Everyone needs to know how much water. We know what it's going to cost, or we have a suspicion how much water do we get and what year types and so forth.
So is that sprinkling you're describing, is that rainfall?
And Director Russ, you mentioned the water supply agreement, water diversion agreement. There actually already is a task force of attorneys that has started meeting to work on developing the form of the agreement, led in part by your own counsel, and we'll look to incorporate the technical data that Tom and David are talking about into that.
Sure.
Anything else, Director? You're good?
No, I'm
Okay. Director Paul.
One more thing. Tom, I think this is probably for you. Tell us just a little bit more about the hydrologic modeling that's still going to be required with regards to impacts of sedimentation as we move forward. I mean, we're talking about this issue right now today, but I want to reiterate to everyone, not only do we have a lot of work to do with regards to flow regimes, but also hydrology. And we don't have a lot of answers to some of the really basic questions there yet either. And that's going to be part of what we'll be doing in the next phase of the work that needs to be done, correct?
Right. So there is actually a pretty good data set for hydrology, right? So we know what the unimpaired Eel River would flow but for the dams. And a lot of that work was developed during the Huffman ad hoc process. and that is currently being updated to go through at least 2022, if not 2023. So we'll have a data set of what hydrology has existed in the past, and then working from that, we'll start to look at different strategies for diverting water, carving a little slice off of those high points to move over. The other really important point that hasn't really gotten going yet is some kind of sophisticated sediment transport modeling, because removal of Cape Horn Dam and all of the sediment that exists there, and even more so the removal of Scott Dam and all of that sediment, you know, there's a lot of uncertainty around those two dam removals. So starting with the easy one, Cape Horn Dam, the construction of either of these facilities, and particularly E2, is going to require an actual physical excavation of sediment right around the dam. They would need to do that anyway to remove the dam. You can't, you know, bang it out if there's rocks falling on it from the sediment pile upstream. So we'll need to dig a big hole to put in the pump station if that was the direction that we went, the wall, take out the dam and so forth. The balance of the reservoir, and Van Arsdale Reservoir is a couple miles long, that's all got sediment in it, and it's going to go somewhere and it's going to move through the system. The other piece, obviously, Scott Dam and PG&E's removal plans. They have postulated in their draft surrender application about a couple of different ways to go about that. One of them is removing the dam essentially in a year, which is going to really release a big block of sediment. The other alternative is, I think, over the course of 4 or 5 years, which means you're going to have a lot of sediment, not as much sediment, but over a more extended period of time. Obviously, you know, it doesn't move that much in a dry year. A lot of it moves in a wet year. All of that is going to be modeled not just for the immediate downstream of Scott Dam or just down to Cape Horn Dam, but I suspect there's a lot of folks further downstream that want to know what sort of impacts they're going to see from the release of that amount of sediment upstream. Whether that is something PG&E is going to do at some point in time is unclear. It needs to be done, and I'm certain it will be done before the final designs for a new diversion facility are in place. It's just unclear who and when and who's going to take the lead on making that happen.
Thank you.
Just on that, I'm curious, does FERC then look at, during the course of construction, and alter the construction schedule based upon whether or not it's a dry or wet year? If the removal of sedimentation is supposed to go a certain way and perhaps it doesn't pan out that way in that particular year, would they push them off for a further period of time?
Yeah, typically the way FERC works is they are not a problem-solving entity. They're an approval entity. And so they will look to PG&E to put forth a plan, and they will then make sure that that plan is circulated. And everybody will get to comment on that, including your board. And based on those comments, FERC has a number of alternatives, one of which is to say, okay, PG&E, everyone liked your plan, go do it. Or PG&E, there's a lot of problems with your plan, and some of these comments are spot on, go answer, figure it out. And they will keep after it until PG&E gets something that is acceptable to everybody, and however many circuits that takes. The general preliminary concept is that the removal would be either take place during a wet year or immediately before what's expected to be a wet year in order to mitigate some of that. But the details around that, you know, that PG&E's in the lead on this, and we're all going to be watching and I'm sure commenting pretty extensively on whatever they come up with.
Thank you. Appreciate that. Director Russ.
We've had a lot of, we've had a lot of discussion on looking at different models and stuff. But right now, currently, I think probably everybody in this room knows that the dams up on the Klamath are being removed. Are there lessons to be learned from what's going on up there I know the rivers aren't exactly the same, of course, but are there some lessons to be learned?
Yeah, I think there,
I can speak just from my own personal experience seeing the results of some of that dam removal. I was there a couple of weeks ago. The setting is very different. The flows that Tom mentioned would be counted on to mobilize that sediment from the removal of the dams on the Eel River. The magnitude of flow like that simply doesn't exist in that watershed on the Upper Klamath Basin. So there's water that's laden with a lot of sediment. It's coming out of the dam at a rate much lower than flow typically flows from the Eel River. So this protracted period of time where it's expected the water will be sort of turbid or muddy looking. I think the idea here on the Eel River is to minimize that amount of time by taking advantage of the flashiness that I mentioned earlier. Those really, really high flows that happen in the Eel River work to the benefit of improved water quality in the Eel River after dam removal. But there are certainly lessons that will be learned about restoration in the former footprint of the reservoirs, and that process is ongoing right now. There's been a tremendous amount of planning. How fish will deal with the ongoing impacts post-dam removal and how quickly they recover from the restoration of the lake bed. Those are all great examples that can be taken from the Klamath dam removals and brought to the Eel for this project.
Great. Again, I'll look to my colleagues. Any final questions of staff? And we do have a recommendation in front of us, which is on the screen, to select alternative E2, and I'll look for a motion. Do I have is that a motion? Yes.
Yes, Mr. Chair, I make a motion to select alternative E2 for transmittal to PG&E as a preferred alternative to be included in this license surrender application for the Potter Valley project.
Thank you. And do I have a second?
Mr. Chair, if I could improperly interrupt just for a second. Director McGordy, I just want to be careful. It's not a preferred alternative because we're not making a CEQA determination. We're selecting an alternative for transmittal to PG&E as information for its application. I just think it's important that we not concern people that we've somehow selected an alternative without doing CEQA on it.
I'm just reading what I have on my agenda. And I will change the motion to reflect the concerns of council.
Thank you.
Thank you.
Keep it as in check. That's a good thing. And is there a second?
So let me ask one quick question of council. So, Scott, the preferred language is what we have up in front of us on the
That is
board.
correct.
That is correct.
Thank you. And I apologize if you've been given a version that had incorrect language.
Okay, I will modify my motion to reflect the proper language which I just could have read off the screen instead of off there, which is select alternative E2 for transmittal to PG&E as information for its license surrender application for the Potter Valley project.
And a second? Great. We have a motion and a second. And with that, I'll ask for a voice vote again. Excuse me. All those in favor of the motion as stated, please say aye.
Aye.
All those opposed? Hearing no opposition, that does pass unanimously with all present. So thank you again very much. Thank you for all the work on this, and thank you for sticking with us through that item. Very important work, so really do appreciate that. We'll move on to item 6B, which is establishing a meeting schedule. And Scott, you want to talk about the calendar?
Thank you very much, Mr. Chair. At your last meeting, my co-counsel, Corey O'Donnell, shared that it was our belief that meeting every other month would probably be an appropriate schedule. At that time, we hadn't had a chance to look at calendars and figure out everyone's exact availability for a meeting on, for example, the second Thursday or the third Wednesday or whatever. We still don't have an exact schedule, but if the board is comfortable directing us to find a meeting time sometime in May, which would continue that, then we would work to find a date and time that worked for all of you. And we would also see if we could find a more regular schedule that would work for the rest of the year.
Any strong opinions on that? We'll just let staff work on calendar.
I agree with that.
Okay,
Sounds good.
great. Thank you very much on that. Then moving on to 6C, which is items for the next meeting agenda. So anyone have anything to offer for staff's consideration moving forward?
So I've thought about this, and I think that one of the things that I would like to start sorting out and putting together is what's happening on this side of the mountain, and in terms of what future projects would affect the new Eel-Russian project. So we have design going on the eel side, but because it's such a long lead time to find funding and plan for facilities, that it would be great for us just to start maybe with sort of an inventory of what we might have available to us. So that would include something like a water resources assessment, studies that are underway, kind of hearing about them. So we know that data from the airborne electromagnetic survey has been done for some of this area. It would be great to actually hear about that and see what has transpired so far. The other groundwater studies that are being done in Powder Valley is an area to potentially store water. Increasing water storage in Lake Mendocino. So we know that Congressman Huffman has got an allocation of $500,000 for initial studies to raise Coyote Dam in the Army Corps of Engineers budget. And we're not sure about if there's a match required. We need to find that out. Really critical information. And then I think groundwater storage is also going to play a very big part in where we put water, because building dams or raising dams is difficult to do, whereas groundwater storage, we got the ground already. We don't have the water rights, but certainly there's times where we get groundwater storage, whether we like it or not. And I looked at my well this morning, and my 2 shallow little wells, and groundwater is at 1 foot. So, when it rains, the ground gets full of water, which is a good sign. So we would like to work with the GSAs and, one GSA, Ukiah Valley Basin Groundwater Sustainability Agency, to see what studies might be proposed or underway, and then also Alexander Valley if there's anything that's going on. So any information that we can start to collate and put together, because this is going to be a long process for us to really design out this system, and the sooner we get started, the sooner we know what we're up against, the better. Lake Mendocino, as it stands now, in a wet year, believe it or not, we might have a hard time storing water. We might be able to transfer it easily, but we might have trouble storing it because there's a flood pool, and we have to make sure that there's room in there in case the watershed's going to flood. And the way that the Army Corps is tasked is to prevent floods, so they don't want it full to the brim. So these are the sorts of things that we have to start thinking about now and coming up with a plan. So I would like us, if we can, to direct our respective staffs to start helping us pull information.
I appreciate that.
I think those are very good ideas, Glenn, and I think that all of the directors should participate in bringing forward items for agendas for this board if they are appropriate in the future. I think it's a new good sounding board, and we'll need to have all of this information as we move forward with concerns about funding, particularly with the water supply that we're going to be allowed to have in the future.
Director Russ?
I agree with that. I just have a question about the, muted myself. Anyway, I'll get it down one of these days. I just have a question about the process. When we do have issues or items that we would like to put on the agenda, who do we contact in that?
If I may, I mean, I was, and I think this is all very good. I think what's true with water, as we all know, is that it's hard to isolate to only talk about the one piece of the purview that we have here as this body when it's all interrelated anyway. And we've had this as a director of Sonoma water, and we have 3 GSAs in our county that Sonoma Water isn't technically responsible for, but yet you are. The reality is that it's interconnected, and all water is interconnected that way. Recycled water, North Bay Water Reuse Authority that we started is also interconnected. And I will look to staff, because I don't want to overburden staff, nor do I want to give them, to be honest, purview beyond what we're supposed to be responsible for. But I know there's also opportunities to have people come in, and as we schedule our agendas into the future, that maybe there's opportunities to do an update or briefing, a white paper, or whatever it may be. And I'm not sure who I should be looking at to see if that's something that that can happen. And I do think that as directors, to be fair and equitable to all, and on both sides of the mountain. I mean, honestly, my concern for the eel doesn't stop at the diversion tunnel. It extends downstream, and I'm curious about how, and again, the big wash or whatever is going to occur there, what the implications of that are, and the timing of it and everything else. So I think there's a lot of different subject matters, and I'm looking to Grant to see if we can't find a way to bring things forward but have it be orderly and not overburden staff, but get the information back out to this body.
I think we were tasked with being the interim staff for a short period of time. If I might, if we could go through the chair while we figure out how to make sure there's a minimal response in the structure. It's not quite put in place. We don't have paid staff for that, but it's important that you have a place to go. And so let us take that back and come back with a proposal recommendation.
Is that acceptable? We can come back and talk about how we can incorporate those updates, and I think hopefully a lot of it would just be coordination with perhaps other agencies and entities.
So for now, we would just direct our comments to the chair? Okay.
Well, I wrote down everything that Glenn said, and if anyone has anything else, we can continue to make that list. I'll make sure that the interim staff at least has that, and then we can figure out a way to, as we move forward as a body, to make sure that those things can come back. I don't disagree with you at all. Everything is related, and it'd be great to be making all these decisions with all the other things that are happening on both sides of the mountain in mind to make the best decisions. Is that okay?
Yes.
All right. Well, I appreciate that very much. I don't know if anyone in the audience has any comment on our meeting schedule and/or items for next meeting. Seeing no one rise, we'll move on then to the council report and go back to Scott.
Thank you, Mr. Chair. I actually have no report for the council report. I will note, just for members of the public, that under the meeting schedule, I should have mentioned we had talked about alternating locations. So May would be back in Santa Rosa at a time and a date that worked for that chamber.
Okay. And with that, we'll move. Any questions, comments? No. Board comment, which we probably already made, to be honest. Glenn?
Just a quick question. Was it easy to park here?
It was, and we're going to work on that when we go back south. Yeah, we apologize. There was, parking sometimes can be a little rough, but we'll make sure that is taken care of next time we meet. And with that, I think we are at the end of our agenda, and just want to say again, thank you to all the staff. Thank you, everyone, for being here today and participating as we embark on this new body, but dealing with the same issues that we've been dealing with for generations. Looking to my colleagues who have been involved. So hopefully good things will come forward. And again, appreciate all the work. And with that, until May, at a date to be determined, we are adjourned. So thank you.